Okay, 2006, question 7. Convergent lens has a focal length of 8 centimeters. So focal length equals 8 centimeters. Determine the two positions that an object can be placed to produce an image that's 4 times the size of the object. So the magnification then is equal to 4. Magnification is equal to V over U. So 4 over 1. Cross multiply gives you 4U is equal to V. Okay. Now if it says two positions, it means one position is going to be real, one image is going to be real and one's going to be virtual. Okay. So you're going to have a real image and you're going to have a virtual image. Okay. Now what kind of lens was a convergent lens? Okay, well a convergent lens looks like that. Okay. And the focal point for a convergent lens is always plus. Okay, F is equal to plus. Is plus. Okay. So focal length is 8. Magnification is equal to 4. So you get 4U is equal to V. Now so we go with the real one first. So your formula then is 1 over U plus 1 over V equals 1 over F. Subbing in, you have 1 over U plus, so instead of V now you're going to have 4U. 1 over 4U is equal to, and instead of F you've got 8. 1 over 8. Okay, adding these now. So your common denominator there is 4U. 4U, you go U into 4U goes 4 times. 4 times 1 is 4. 4U into 4U goes once. 1 times 1 is 1. So there you go, equals 1 over 8. So 4 plus 1 is 5 over 4U equals 1 over 8. Cross multiply now. You get 5 times 8 is 40. Is equal to 4U. So divide by 4, U is equal to 10 centimeters. Okay. So that's the first place you can put the object to get a magnification of 4. Okay. Now for the second location, it's going to be a virtual image. Now when it's virtual, it means V is going to be minus. Okay, V is going to be minus. Now U is always plus because U is the object distance, and the object distance, you know, it's a real object, so it has to be plus. Okay, U is always plus. So, and we know that V is equal to 4U. V is equal to 4U. So if U is plus, always going to be plus. Well, 4 times a plus number will always give you a plus number. So you got to make it minus. Because for a virtual image, V has to be minus. So V is equal to minus 4 times U. Okay, because we know U will be plus. So V is equal to minus 4 times U. Okay. Now once you do that, you just proceed as the last time. 1 over V equals 1 over F. There's your formula. So 1 over U is just going to be 1 over U. And now instead of V, we're going to have minus 4U. So it's going to be minus 1 over 4U is equal to 1 over, and F we said was 8. Okay. Now adding these again, common denominator is 4U. U into 4U goes 4 times 1 is 4. And that's going to be minus 1 is equal to 1 over 8. Okay. So 4 minus 1 is 3 over 4U equals 1 over 8. Are we still on the screen there? Yeah, move it up a bit like that. Okay. Cross multiply, so 3 times 8 is 24 equals 4U, so U is equal to 6 centimeters. Okay. So our two object positions, locations, which will give us a magnification of 4 are 10 centimeters and 6 centimeters. Okay. 10 centimeters will give us a real image. 6 centimeters will give us a virtual image. Okay, and both will have a magnification of 4. Now, so if you see that two positions, it means one is real and one is virtual. The power of an eye when looking at a distant object should be 60 per meter. Okay, this is the next bit of that. A little bit of space here. Okay. Now, when you're talking powers, there's only two formulas. Okay, power is equal to 1 over F, and if you're adding powers, power total is equal to power 1 plus power 2. Okay. So the power of an eye when looking at a distant object should be 60. A person with a defective vision has a minimum power of 64. Calculate the focal length of the lens required to correct this. Okay, so the person's eye, so you'll have the power of the person's eye plus the power of the person's lens, and that together should give you, let me just read it again, the power of an eye when looking at a distant object should be 60. So that should give you a power of 60. Okay, okay. So you have to work out the power of the lens required to give you a power of 60. So there's your formula. power total equals power 1 plus power 2. So 60, which is the power we're looking for, equals the power of the person's eye. What is it? As a minimum power of 64 plus the power of the lens. Okay, P2. Okay, so we're looking for the power of the lens. So I'll bring the 64 across. 60 minus 64 equals the power of the lens, or P2. So P2 then is equal to 60 minus 64, which gives you minus 4 units of power per meter, or diopters. You could also say minus 4 diopters. Okay, like that. Okay, that's it. Now, if you see a minus power, okay. Now, if you see the minus power, it means it's a divergent lens like that. Okay, divergent lens always has a minus power. Okay. So what do we ask for? So we're not asked for the power, we're asked for the focal length. Okay, so power equals 1 over F, F equals 1 over P. So it's just subbing in. So focal length is equal to 1 over minus 4, which gives you minus a quarter, or minus 0.25. What are the units? Well, it's focal length, so it's meters. Okay, minus 0.25 meters. Okay, and that's that question done. Okay, calculate the focal length. What type of lens is used? Well, we know when we see minus, we know it's this kind of lens. We know it's a divergent lens. Okay, diverging, because the divergent lens doesn't bend the light in; it actually bends it out like that. Okay, so we give it a minus power. Name the defect. Well, if you need a divergent lens, it means you're spreading the rays out before they come to the eye, which means, let's just see our eye. So that's your eye there, and there's the retina there, retina. Okay, if you need to spread the rays out, it means that the image is coming to a focus short of the retina. Okay, so you need to spread it out with your divergent lens. Okay, spread those rays out before they come to your lens, so it'll actually come to a focus on the retina. Okay, so in other words, they're short-sighted. Short-sighted. Okay, if it falls short of the retina, it's short-sighted. Okay, if it falls behind the retina, it's long-sighted. Okay. Okay, this is 2004 5E. Okay, it's another power one. Two convergent lenses. What is a convergent lens? Looks like it's that far there. Okay, so when you see a convergent lens, you know a power is going to be plus. Okay, and it's also focal length is going to be plus as well. Each with a focal length of 10. So F is equal to 10. Now it's centimeters. Okay, so that has to ring a bell because we want to change to meters. Okay, I'm just going to change my pen there now. Okay, centimeters. So straight away now we're going to change that to meters. Okay, so centimeters to meters, you're going to divide by 100. So that's equal to 0.1 meter. Okay, now use your calculator if you can't do it in your head. Okay, the two of them are placed in contact. What's the power of the lens combination? Okay, so if you have two lenses in contact, the formula is power total equals the power of the first plus the power of the second. And make sure you change the powers before you actually add them. Don't add them in focal lengths, okay? So the power equals 1 over the focal length, okay? Which in this case is 0.1. So it's 1 over 0.1, which is equal to 10, okay? So the power is equal to 10 per meters. And the power total then is equal to power 1, which is going to be 10, plus power 2, which is 10 again, which is equal to 20 per meter. Okay, so that's the answer, 20 per meter. Now always, if you're using this formula, always change, first of all get your units right, meters, and then change the focal length to power before you add them. Don't add 1 over F plus 1 over F, okay? Change the powers first and then add them, okay. Okay, this is 2002, question 12, part B. Okay. Power of a normal eye is 60, so the power equals 60 per meters. Short-sighted person's eye is a power of 65 per meter. Calculate the power of the lens required to correct this defect. Equals question mark. Okay, so normal power is 60, person's eye is 65. What's the power of the lens? Okay, so the formula for these type of questions, as you know, power total equals power 1 plus power 2. Okay, now what's power total? Well, that's what we're trying to get, okay, which is the normal eyesight. Okay, so if you're an optician, you add the person's power of their eye to the power of the lens that you're going to give them, and the two of them together should give you a normal eyesight. Okay, So the power total is going to be what we're looking for, which is 60. And that's going to be equal to the combination of his eye, his or her eye, which is 65, plus the power of the lens, okay, which we're going to stick in there. Okay, so 60 minus 65 equals power of the lens. So minus 5 is equal to the power of the lens. Okay, so question 1, what's the power of the lens? Well, the power of the lens is equal to minus 5, and the units are per meter. Okay, minus 5 per meter. Now when you see minus, you always know it's this type of lens, which is a diverging lens, diverging. And when you see divergent, you know it's short-sighted, short-sighted, because the divergent lens spreads the light rays out rather than bringing them in. Okay, so it has a minus power, and it also has a minus focal length. Okay, and it's to treat people who are short-sighted. Okay. Now you also were asked for the focal length, so power equals 1 over f, so f then equals 1 over power, which is equal to 1 over minus 5, which gives you minus 1/5, or minus 0.2 meters. Now the units of focal length is just a meter, okay, so 0 minus 0.2 meters, okay, and the minus again tells you that it's a divergent lens, okay. Okay, we're going to do a critical angle 1, so this is 2010, this is 2010, question 5b. Okay, what is the critical angle of a sample of glass whose refractive index is equal to 1.46? Okay, now your formula in your log tables that links the two of those guys together is n equals 1 over sine of the critical angle. Okay, now we want C, so let's just put that over 1 and just cross multiply, so you get n times sine C is equal to 1 times 1, which is 1. Okay, now I don't want n sine C, I want sine C, I want C on its own, so I'm going to bring the n over there, divide both sides by n, gives me n over C equals 1 over n. Now I don't want sine C, I want C. So C then is equal to the inverse sine. To get rid of that sine, you got an inverse sine, okay? But you got to do the same on this side. So inverse sine 1 over n. Okay, now I've got C. Now so C then is equal to the inverse sine of 1 over 1.46. Now you type that into a calculator. Let's get a calculator. Type it in. Here we go to now. Okay, type it in exactly as we see it. So inverse sine, shift sine, gives inverse sine, fraction 1 divided by 1.46. Okay, like that, enter. And we get 43.23. So 43.23. Now what is a critical angle? So the angle, so its units are degrees. Okay. Yes. Okay, just a quick recap on the types of mirrors and lenses there are. Okay, so the straight mirror that looks like that is this is the silver surface, is called a plane mirror. Then you have the mirror that bends in like a cave. Okay, and this is the side you're looking at. This is called concave, and this fella here then, the one that bends out. Okay, and this the side you're looking at is called convex. Okay, now then you have lenses. Now I'm going to draw the one that bends out like that beside the concave. Okay, this one is called a converging lens, and this the opposite one is this one then, which is called a diverging lens. Okay, now what are the things we should know about these? Concave lens, the focal distance is always plus, okay, but a convex lens we make our focal point minus, okay, because it's actually behind the mirror, okay, the mirror, sorry, okay. With a concave mirror, the focal point distance we make it plus. With a convex lens we make the focal point minus, okay. With a convergent lens, then this kind of follows this fella, okay. F is always plus with this fella, And the divergent lens is a bit like the convex mirror in that the focal length for this fella is always minus. Okay, now lenses have powers, and his power is always going to be minus, and his power is always going to be plus. Okay, so here we have the pluses and here we have the minuses. Okay, what does a convergent lens do? Well, it bends light in. Okay, and we use it to treat people who are long-sighted. Okay, long-sighted. Okay, what does the divergent lens do? Well, it bends the light out. Bends the light out, and we use it to treat people who are short-sighted. Short-sighted. Okay, so if you're doing a question, you get a minus power. It means it's a divergent lens, and it means the person is short-sighted. If you get a positive power, it's a convergent lens, and the person is long-sighted. Okay, anything.